This example, I'm going to go over a 2 by 2 factorial analysis of variance using SPSS. So in this hypothetical example, let's say we have one independent variable that represents the presence or absence of a statistics lab, and another independent variable that represents the presence or absence of online tutorials for a course, and each row represents a student. So a given student can be in a condition that has either the presence or absence of a lab and also the presence or absence of an online tutorial. And the last column here represents, let's say, that's the final exam grade. So to run the analysis of variance, the factorial analysis of variance, we'll go to Analyze, General Linear Model, Univariate. We will enter as our dependent variable our outcome variable, the grade. We'll put lab and online tutorial as the fixed factors or the independent variables. And for now, let's ask for plots of the independent variables so that we can take a look to see if, in case there is, if there are main effects and interactions, we can get an idea of the nature of them. So I ask for both possible plots there, and under options, I'm going to ask for here. This will give us all of the means that are estimated by the model. We can also ask for descriptives, which will also give us the means, which may be slightly different from the means estimated by the model. We'll ask for estimates of effect size, and for now that's all we'll ask for. Click continue, and I'm going to paste the syntax. And because we'll be working with the syntax in a minute, and we'll highlight the syntax, run it, and we'll take a look at our output. Our output first table tells us how many participants there are in the following levels of each independent variable. Then we have a table that gives us the number of participants in each cell and the mean and standard deviation for each cell in our 2 by 2 factorial design. So for example, in the absence of a lab and the presence of an online tutorial, the mean grade is 74.84 and the standard deviation is 1. So that's the basic descriptive statistics, observed descriptive statistics for our samples. And then here we have the Anova table itself. Of most importance to interpret is the main effect of lab and online tutorial, and then also the interaction. So the main effect of a lab here, our F ratio is 13.83, and our p-value is 0.001, and our partial eta squared, which is our effect size measure, is 0.278. So there seems to be quite a sizable effect of lab. If we look at the means themselves, we can see that in the presence of a lab, the grades are significantly higher than in the absence of a lab. Now the effect for online tutorial is not as strong. Depending upon how strict we are about interpreting our alpha. Let's say if our alpha was 0.05, it doesn't quite reach that cutoff. So we might say that the effect of online tutorial was relatively, at least relative to the effect of lab, was relatively weak and not quite statistically significant. The mean for the presence of a lab was 78. Online tutorial. The mean for a presence of online tutorial was 78, and the absence was 76. Of most interest here, we see that we do ever so slightly have a statistically significant interaction between the presence or absence of lab and the presence or absence of an online tutorial. So we'll go ahead and try to interpret that interaction. So what that's telling us is that the effect of one independent variable on the dependent variable is depending upon the level of the other independent variable. So to look at the graphs, we'll get at least a preliminary view of what might be going on. So if we look at the absence versus the presence of lab, it seems that lab, as we saw, does significantly increase grades. So having a lab seems to lead to higher grades, I should say, than not having a lab. But we see that that effect is much stronger in the presence of an online tutorial. So there's, in a sense, a synergistic interaction between the lab presence or absence and the online tutorial presence or absence. Whereas for the condition where there is no online tutorial, the effect of the lab is weaker and perhaps non-significant. Looking at it the other way, if we can look at the effect of online tutorial, there seems to be basically no effect of online tutorial when there is no lab. But when there is a lab, the effect of the online tutorial is pretty strong, whereas online tutorial leads to about a B average in the when it's present. Looking strictly at when there is a lab, the online tutorial yields about a B average, but then when there is no online tutorial but there is a lab, it yields about a high C average. So that's going to be the nature of the interaction that we're going to decompose. But we may want to go ahead, instead of just eyeballing it with graphs, we may want to conduct simple effects and simple comparisons. So we're going to look at it both ways. So I'm going to create a copy of the estimated marginal means subcommand that asks for the tables for lab by online tutorial. So we're going to have two, for now, identical subcommands there. For the first one, I'm going to type in compare, and I'm going to put in parentheses lab. So that's going to give us the simple effect of lab at each level of online tutorial. Now here we can ask for some form of adjustment if we want to adjust for type 1 error, inflation of type 1 error for running numerous tests. We're not going to do a ton of tests here, but I'll just use the SIDEC adjustment. And then we'll also ask for the simple effects of online tutorial at each level of lab. So we'll look at the simple effects analysis both ways here. So if there's a more theoretically informative or predicted way, you would look at it that way. If not, it's okay to explore multiple ways of interpreting the simple effects. So now we'll highlight the syntax, click run, and all the output will be as it was before, except when we look at the estimated marginal means tables, we're going to see that below the table that gives the means for all of the cells, we have a table doing the pairwise comparisons, and then also a table doing the simple effects analysis, which will be identical because there's only two levels of the independent variables in this example. The simple effects analysis p-values will be the same as the pairwise comparisons, because the simple effects themselves are essentially pairwise comparisons. So here we have, in the presence of an online tutorial, it seems that the absence of the lab yields significantly lower grades than the presence of the lab. However, in the absence of an online tutorial, it seems that lab presence does not have a statistically significant effect, and the effect is considerably weaker. So that's how we can describe the interaction, or one way we can describe the interaction. If we wanted to instead look at the simple effect, so this is the simple effect of lab at each level of online tutorial. If we wanted to instead look at the simple effect of online tutorial at each level of lab, we would see that when there is no lab, the difference between the presence or absence of an online tutorial is pretty small. Is incredibly small, and certainly we're not able to reject a null hypothesis here because the p-value is incredibly high. On the other hand, when a lab is present, so when a student takes part in lab, the difference between the presence and absence of online tutorials in final exam grades is considerable. So there's about a 4.7 point difference, and we see that that is a statistically significant difference. So it looks like when the lab is present, when the online tutorial is present, it yields to significantly higher grades than when the online tutorial is absent, looking at the condition where there is a lab. On the other hand, when there is not a lab, there's no difference between the presence and absence of an online tutorial. And in this table here, we have essentially the same information. This is the simple effects analysis itself. Now, in a situation where there's more than two levels to an independent variable, the simple main effects depicted in this table may be different, or will be different, in terms of the p-value reported from the p-value reported in the simple pairwise comparisons, which are given in this table.